help save our environment. We believe our new technological patent-pending system has put us far into the 21st century. We have developed one of the world's most efficient energy-saving systems so far as we know of outside of sea, wind, or sun. On May 27, 2009, our patent-pending system ran our test 17-foot AC hybrid electric boat full speed for 2.5 hours. It should have used 5.625 gallons per hour. Our generator used 93.7% hydrogen and 6.3% gas, or 0.35 of a gallon of gas per hour, with no real measurable loss in our hydrolysis system. To refuel, add distilled water, a chemical, gas, or diesel. Sailors, replace your gas or diesel motors and become a hybrid AC electric boat that costs so much less to run and go to greater distant horizons. Using our patent-pending system, in our dynamometer testing, we obtained 40 horsepower from our AC electric motor. Throughout the RPM spin range from the generator, there is an automatic 30% savings. The left side output black wire coming from the VFD has more amps going to our AC motor, whereas the right side input yellow wire from the generator has less amps going to the VFD. Farmers use this same system that produces electrical power for hybrid boats to produce electrical power to run water well pumps, booster pumps, or whatever. Yasakawa is the first speed drive to be presented with the Covenant FIDE certification for saving electrical energy from the Mexican government on their speed drives, the V1000, P7, E7 IQ pumps, and receive federal financial help to buy these drives, plus there is technical support. Water well pumps. We have modified our system from our AC electric boat to run water well pumps and greenhouse fans. We have 3 farms in California and 2 city well pumps in Mexico using their electric company for electrical power. One small city well pump is saving 50% in horsepower. The other city 150 horsepower well pump in El Galdo, Mexico is running at a constant high torque load application. The 150 horsepower well pump at 1782 RPM is running at 1701 RPM and pumping water uphill. It is saving 26.25% in electrical power while using only the horsepower required. There is such an overabundance of water, they must turn off the well pump 19 hours per week. Before, it was never turned off. Water well pumps. Flood, drip, or sprinkle. Standard 3-phase motors become variable speed motors with no power surges. Save up to 50% in electrical power, plus no wasted water. Water pumps can run from a minimum RPM to a maximum RPM. The adjusted controller produces only the amount of water that is set for and pay only for the electricity on that setting. The horsepower can be decreased or increased.
Wow. 30, what is this?
Volts?
This is volts and this is amps?
Yeah, let's do it like this here. Let's move this here.
Oh yeah, this is the volts, or the voltage is selected there. It's 32 volts, awesome. And this is the amperage. Selected on amperage, 0.9 amps.
You see, I don't think we're at full speed yet. Nursery greenhouse fans. Example, 3-phase, 1 horsepower motor can use only 32 volts at 0.9 amp at 688 RPM, or run up to 150 volts at 1899 RPM, instead of using 240 volts at 3.5 amps. Ever-changing greenhouse temperature controls the constant changing speeds of the greenhouse fans, providing savings up to 66% in electrical power, plus no power surges, and it maintains an even airflow throughout the greenhouse.